Go to page 28 to find out who Haji is. I'm here on page 28. Here you go, engineers. Here is K28, which is an auxiliary. So where does this auxiliary work from? Look, sir, the post comes from here like this, and it goes through this loop like this, then this loop like this, then this loop like this, then it comes back here like this, then it goes back like this, then it goes to operate from K28. So what are the things in the middle here? What is all the stuff you have here in the middle? Look, engineer, quite simply, you are talking to me about whom? You are talking to me about attempts. That's right. You are talking about an attempt, or talking to us about a line, or talking to us about anything. Let's always say that at the high voltage level and extra high voltage, any bay or any cell you have will have a protection cell, main protection 1 and main protection 2, okay? Which is, or they tell you yes, yes, FM, which is the first main, first FM, FB, or FM, SB, okay, which is the first or, and second protection, or main 1 and main 2, whatever it is, there are 2 protection cells. All right, nice. I'm speaking to you generally. I'm not focusing on protection. The people who attended with us are the transformer protection and line protection. I spoke about that in detail. But here I'm talking to you about why the transformer has main protection 1 and why it has main protection 2. There's also bus bar protection, and you have breaker failure protection. These are the 4 things that can trip your feeder or your breaker. Either main protection 1 is activated, or main protection 2, or you have a breaker failure on the bus bar, which trips your breaker, or the bus bar itself has an issue, which trips your breaker. Here, you'll find that you're talking to me about the bus bar protection cell, which contains a set of lockouts. The lockout, which is 86, is a latch relay that prevents or performs something called close block. What does this mean? You have something called 94 and something called 86. The 94 is referred to as the ANSI code for the trip relay, and the 86 is the ANSI code for the lockout relay. What is the purpose of both of them? The purpose is that the 94 performs a trip of the breaker when the breaker experiences, meaning the fault has been cleared. This relay or trip relay automatically resets. However, the 86 engineers continues to operate even after the fault is cleared. So what is its purpose? Its purpose is that I use, as you can see in front of you, a set of normal close contacts from it. The purpose of this is to perform what is called a close block, which means preventing the closing operation until the maintenance person arrives at the station, identifies the problem, fixes the fault, and then resets your relay. This is similar to an auxiliary relay, but is designed to withstand high currents and is used for fast tripping, meaning it operates with a response time of less than 10 milliseconds to trip the circuit breaker. Here, you will find a normally closed contact from 86 BP, which is the lockout for passport protection tripping, and 86 BF, which is the lockout for breaker failure tripping. If you continue here, you will find the main protection 1 with 86 T1, 86 T2, 86 T3, and 86 T4. In Saudi Arabia, they use 4 lockouts for transformer protection, 1 for differential protection, for transformer protection 1, for differential protection, 1 for backup protection such as overcurrent and earth fault, 1 for mechanical protection, 1 for restricted earth fault. So you have 4, yes 4, and sometimes there is 1. For differential and restricted, 1 for backup, which is overcurrent and earth fault, and 2 divided by the mechanical protections. In the end, all of them are logouts, all are normally closed contacts. So if any of them operates, it will result in disconnecting your transformer. Therefore, the transformer here should open to prevent the breaker from reconnecting until a person comes to the station and sends a signal. All right, great. So we understand that I must say the protection must be reset. Okay, then you will find other conditions here. What are these other conditions? It tells you that the trip circuit supervision, which we will talk about directly after finishing the closing circuit, must be healthy. What does it mean that it must be healthy? It means that now I am closing the breaker, and it is not logical that when I come to close the breaker, after closing it, I discover that there is a problem with its trip circuit. Consequently, in the event of a fault, or if I want to open the breaker, I find myself unable to open it. As long as I can't open the breaker and a fault occurs, the breaker failure function will immediately activate. and I will find the station or the bus bar completely out. So it is not logical as long as I know in advance that the breaker's tripping circuit has an issue. So here you have different logics or people who think in different ways. They come and tell you what it must be. 2 trip circuits, peace or healthy. You have another one come and tell you one of them should be healthy. Okay? Who is this engineer Rashad? These are the contact routes of the relay routes that are used in trip circuit supervision, which I will explain to you. It may be about 1/3 of an hour from now. Okay, this is good. If all of this talk works, K28, what's wrong with this K28? It will work. It will work at 28. Okay, so K28 here, if it operates properly, it will eventually activate K11, which will then go and shut off what? The breaker. But before I go to the breaker and shut it off, let me summarize this for you completely. My starting point was here, where the DC came from the DC-DP and reached here on the MCB called F31. When I turned on F31, I found the DC exiting from my side with the negative running so straight through. And the positive branched off, not directly, and the other branch passed through a selector switch. The selector switch has more than one position, something called off, something called emergency, something called local, and something called remote. These are what we call the control modes, which means more than one way to lock or gives authority to lock through specific places. Off means there is no control, and naturally you won't find it. Emergency means you are in an emergency situation and you are in front of the cell itself. So you use the buttons available in the cell itself to lock it. Local means that in the past, you used to have something called a control panel. And I told you there was something called a mosaic panel. Well, engineer, does that mean it's been removed? No. If there are old stations, they might still exist. But the new stations operate with a CES system. The alternative is the relay IED device that you have in the GS located in the LCC panel. And what about the remote, engineer? The remote was used in the past. Now, from the control room, you go to the RTU, then to the SCADA. The SCADA used to send it to you, but now instead of the control room, there's just a computer. The whole idea is that all these PCUs are IED devices connected via fiber optic to a set of switches. In the end, all these switches output through one fiber optic and another redundantly connecting to an industrial PC, which is your case. The system is equipped with a sophisticated fiber card, a crucial component that allows users to access and operate a large high-definition LCD screen. This screen is not just any display. It provides a comprehensive and detailed map of the entire station, enabling users to navigate and manage various station operations efficiently. The functionality of this system is highly dependent on the type of policy you have in place. Whether your policy is basic, offering limited access and features, or advanced, providing full access to all functionalities and real-time updates, the system adapts accordingly to meet your specific needs and requirements. All right, great. So if I choose emergency, this contact will close. And if I choose local, only that will close. And if I choose remote, only that will close. The one that closes will pass the positive through them, right? Right. So I went to the closing circuit here, and when I came to the closing circuit, I found that if I choose emergency, there will be a positive coming here. If I choose local, there will be a positive passing like this. If I choose remote, there will be a positive passing like this. If I choose emergency to close from my cell, I found that I need to press select and then close. What does this mean, engineer? If you come here like this, here it is. All right, engineer, you see the circuit breaker here, and here are the switches, and here is the ground, and so on. Next to everything, engineer, you see this switch with a push button next to it, the switch with a push button next to it, the ground with a push button next to it, the breaker with a push button next to it. This is called select. And here you have two general push buttons, one for close and one for open. If you press close, which of these components will close? It will close the one you have selected. All right, he said it's more efficient. Instead of having to put two push buttons for each piece of equipment, one for close and one for open, and repeating this process over and over. No, I will use just one general close open button. When I press close, it should close all of them, but which one will it actually close? The one you have selected. So here I use the single line diagram on my LCC panel to control what? To control this breaker, which we call the emergency mode. Emergency, boot. All right, what do we call this? I will press select and then press close. So what is this close? The close is a push button that activates the coil named K301, and the push button open activates the coil named K302. Maybe 301, and the push button open activates the auxiliary, which is called K302. All right, each push button has the other push button with a reverse contact. Why? Because if you accidentally press both with your hands at the same time, neither will activate, so you won't have a close or an open. So here, when you press the close push button, this contact closes and that contact opens. All right, so here, only this will pass the DC and give a close command. If you press open, this one closes here and that one opens there. So the DC only passes from here and gives an open command. If you press close and open, this one closes in and that one closes, but this one opens and that one opens. So neither will pass positive, nor will it pass positive. All right, very good. So if this passes, it will bring you positive down here. Okay, here, if you choose local or remote, you'll find them coming here to the same terminal block that goes to the PCU. The PCU comes from its screen. If I choose the local mode, as we will learn tomorrow, there is a signal that will go to the PCU telling it that you are now in local mode, and it will control from its screen. You choose the equipment you want and press close. If you have selected remote and try to choose the equipment and press close, it will tell you you are not authorized, because it will say relay in remote mode. This means that only the operator sitting in the control room can press close, and it will accept it. In both cases, you have a contact here that will close, and it will return here with the DC. Whether you are in emergency, local, or remote mode, they will all go down to this lower branch. This branch here tells you what? It tells you that the breaker is in the test position. In the test position, it means the blades before and after it are open. So how many blades do you have before it? 2. And how many blades after it? 1. So all 3 are open. The DC will eventually connect from below us, okay? If you choose emergency, local, or remote and give a close command, whether through emergency, local, or remote, but the breakup is not in the test position, meaning the breakup is in service. What does in service mean? It means the blades were closed. If any of the blades are closed, then this branch will not be complete, right or wrong? Right. So if you choose emergency and press close, you will get the positive like this. And if you press local or remote and give a close command, or choose local or remote and give a close command, the positive will loop from here like this, return here like this, go down here like this, and pass through to reach you here. Okay? If you choose emergency, then the push button here for the emergency, where is it? Here it will close, and at the same time, it will also close for you here. And if you choose local or remote, then the local will close here, and the remote will also close. It will close here. Okay. Now, I'm talking to you here, the test is no longer present, so it goes another way. The service path. So to close in the service position, the breaker must close under synchronization. So if you are in local or remote, synchronization is done automatically through the PCU. As long as the PCU sees synchronization, it will close its contact. And if you haven't selected the emergency mode because the PCU failed, the DC dropped from it, whatever the case, you will start to bring a trolley with it. Meters, 1 to measure voltage difference, 1 to measure angle difference, and 1 to measure frequency difference. You look at it, which is the synchroscope, and you are the one who looks at it in the end. When synchronization happens, you press a push button to close. All of this, it will come to you here, but for it to come here, the service position conditions must be met. What are the service position conditions? The service position conditions are that the main disconnector, the one below, is completely closed, and one of the buses is closed, or they are both closed. Additionally, since I am a transformer, the downstream circuit breaker is racked in. You said it's nice, okay, so these are the interlocking conditions. But I also add that I did synchronization a while ago, so what ensures the synchronization conditions, live dead or dead live, is that it is read correctly. It's very nice. I like delta V, delta F, check phase to phase, meaning phase-to-phase voltage with phase-to-phase voltage or phase with phase. And usually we always check a phase from this VT with a phase from that VT. So suppose you already have an issue with one of the other phases, meaning there's an open circuit in one of the other phases, and you went ahead and closed the breaker. Why would this be a problem, engineer? It would be a problem because if you close and the synchronization was correct, but there's an issue with the phase, then as soon as you close, if any problem occurs, the voltage at the relay station might not be able to trip correctly or identify the existing fault properly. So I need to make sure everything is in order. To ensure everything is fine, I have a VT, the VT of my line as a feeder, and a VT coming from the bus bar for my line. I have verified several conditions. All right, my condition is that the VT isolator is closed, the VT MCB in the box above is closed, and the VT MCB in the LCC below is closed. So these are the three conditions above. Then I came down here and found the contactor. One of them checks the VT of the upper bus, and one of them checks the VT of the lower bus. This also checks the three things. The VT isolator is closed, the VT MCB and the VT box is closed. The VT MCB in the LCC is closed, and the other one is the same way. So it activates the release button, which closes here, and what do you get in the end? Up to this point, whether I am in the test position or the service position, I must ensure that all protections are reset. In addition, the trip circuit of the circuit breaker must be, in this case, there is an 11 which will activate and close the contactor for you, okay?